Hello students, welcome to my YouTube channel Easy Mathematics. Again we are here with some more problems on probability, and these are some tricky problems. So the first problem is the face cards are removed from a pack of 52 cards. Then 4 cards are drawn one by one from the remaining 40 cards. What is the probability that 4 cards belong to different suites and different denomination? So what is the problem given? Any pack of 52 cards means I hope you know that in a deck of 52 cards there are these 4 type of suites and there are total A to K 13 cards for each suite. Now face cards are J, Q and K. These are the face cards. If these cards will remove from all suites, then that means this portion will be removed. So after removal of this one, the remaining are 40 cards we have. Now our requirement is find out the probability that 4 cards belong to different suites and different denomination. We should draw 4 cards from this pack. And these 4 cards of different suites, that means one from here, second one from here, third one from here, fourth one from here. And different denomination means if once you select suppose this one, then this remaining 3 it is not possible to select. We are supposed to select from this remaining. Now in the second denomination if we select this one, then we have to select from this remaining portion. If we select this one from the third type of card, then the remaining is we just leave the remaining portion and we can select from this only. So in this way we have to select. So accordingly 4 cards can be drawn out of 40 cards one by one in this way, that is 40 first. There are 40 choices, then 39 choices, then 38 choices, then 37 choices. So if we multiply these all, then this is the total number of ways by which we can draw the 4 cards. Now the number of ways in which 4 cards belong to different suites and different denomination is, from the first it is the total one type of denomination is 10 cards, out of that 1 we have to select. From the second type of card we have 9 different denominations, and out of that 1 we have to choose. From the remaining 2 8 cards are there, and from that 1 card we have to choose, and from the remaining the last denomination 7 cards from we have to choose only 1. So if we simplify, then we will find out it is the 10 into 9 into 8 into and 7. So these are the favorable cases and these are the all possible cases. So which is the total number of favorable cases? Hence the required probability is the favorable cases divided by the total number of cases. So it is 21 divided by 9139. This is the answer. Now the second question is a pack of 2 n number of cards, n of which are red and another n number of cards are black. It is divided into 2 equal parts and A cards are drawn from each. Find the probability that the card drawn are of same color. So now at first a pack contains 2n number of cards. Among that n number of cards are red and remaining n number of cards are black. Now it is mixed up properly. And after that it divided into 2 equal parts. So if we divide it accordingly to equal parts, so 2n cards, among them n red and n black, it divided into 2 equal parts. One contains n and another contains again n. So definitely the first part contains suppose k red cards, then n minus k black cards, and then the second part definitely contains n minus k red cards and the k black cards. Now here the k may be 1, 2, 3 up to n minus 1 anything. So the probability for both the drawn card are of black. That means our requirement is what? That find the probability that the card drawn are of same colors. So from both the parts one card will be drawn and both the card will be of same color. So the probability for both drawn cards are of black. Its probability is what? In the first half of the card there are n minus k number of black cards out of n cards, so its probability is n minus k by n, and from the second part k number of black cards are there out of n, so its probability is k by n. Again the red card if it is, then it is k by n into n minus k by n. So the probability for both the drawn cards are of same color. It is definitely either both are black or both are red. So if we add these two probabilities, then we will find out the required answer. So this is 2 into n minus k into k divided by n square if we just simplify this one. So hence the required probability is what? That a number of cards are drawn. A number of means any number of cards can be drawn here, so that it is from both the set we can draw the same number of cards and both are the same color. So it should be then, if k is equals to 1 to n minus 1, that means total n minus 1 possibilities are there. So that if the k value is 1 to n minus 1, that means we are going to generalize the result. That's why k, we don't know how many red cards are there, how many black cards are there. That's why k value, depending upon the k value, it will change. So accordingly, when k is 1 to n minus 1, then if we add all those, then we will find out the total probability. So if we do so, then its summation means here 2 is independent of k, n square is independent of k. So we can take both of them out. So it is 2 by n square. Then the remaining portion is n into k. So n can be taken out, summation will be taken, and k minus of k square. So we will take this one. So it is n 2 divided by n square into n of, here k, it is 1 to n minus 1 times addition. So its summation is n minus 1 into n divided by 2. And it is k square, its summation, that means 1 square plus 2 square, its summation is n into n minus 1 into 2n minus 1 by 6. So if we simplify, we will find out n square minus 1 divided by 3n is the required probability. I hope you understand the question, and we should go for the next one. So now it is an urn problem. An urn contains a number of white balls and b number of black balls, from which k balls are drawn one by one and they laid aside without noticing their color. Just draw the balls and keep them aside without noticing their color. Then one more ball is drawn. Then find the probability that it is a white ball. So what happens? There are two urns. First urn contains the one urn which contains a number of white balls and b number of black balls. K balls we will draw from there and keep it aside without noticing its color. After that, k plus 1th ball when we draw, then we will find out that this ball is white. We should find out this probability. Show the total k plus 1 balls drawn from a plus b balls. So the total number of ways to draw k plus 1 balls from a plus b balls are definitely, it is first there are a plus b ways, then a plus b minus 1 ways. In this way it is a plus b minus k ways. Since the last ball drawn is white, we should choose one white ball from a white balls in a ways. There are total a white balls now. That's so why the last, that is the k plus 1th ball is white, that can be chosen out of a balls only. So then k balls can be drawn from the rest. That means the k plus 1th balls would be chosen from the a number of white balls, and there are definitely a number of ways are there. So the remaining k balls should be chosen from the remaining balls. So the remaining balls are a plus b minus 1. So out of this, when we will choose, then it is this is the total number of way, that is a plus b minus 1 into a plus b minus 2. In this way, a plus b minus k ways are there to choose the balls. So the total number of favorable cases in which the last drawn ball is white in k plus 1th draw is this one. Definitely these are the favorable cases. With that, we should multiply a, because the k plus 1th ball drawn by a ways. So hence the required probability is what? That is the favorable cases divided by the total number of possible cases. So this is the favorable cases, and total number of cases are this are. So if we divide these two, then we will find out. If we simplify, then it is a divided by a plus 1. Oh, I hope you understand. Now it is the problem on dice. Two dice are thrown n times in succession. What is the probability of obtaining double 6 at least once? Hence, find the minimum number of throws so that the probability of obtaining double 6 at least once is less than 1 by 2. So first it is given that two dice are thrown n times in succession, Then find out the probability of obtaining the double 6 at least once. First of all, when two dice are thrown n number of times, then they are double 6. The occurrence, that is both the die get the value 6, its chance is very less. So our requirement is the find out the probability that at least once out of n succession of throws it will be appear. So first of all, let one event A is there, so that event A will represent that there is at least once double 6 in n throws of two dice is succession will happen. So therefore its complement means the where the no 6 will be appear on both the dice. So its probability is 35 by 36, because if two dice are thrown, then total 36 sample space are there. Out of that, only one sample space contains 6 on both the die. So the remaining 35 sample spaces are there which are not favorable to the case that both the dice shows the 6. So if it is thrown n number of times, then the probability of A complement should be 35 by 36 to the power n. So that will imply probability of A is equals to 1 minus probability of A complement. So that is 1 minus 35 by 36 to the power of n. So the required probability is PA, that is 1 minus 35 by 36 to the power n. Now it is given in the question that hence find the minimum number of throws so that the probability of obtaining double 6 at least one is less than half. Now our requirement is to make this probability less than half. That is, probability of A less than half means probability of A means we know it is 1 minus 35 by 36 to the power n. So that is less than half. So if we simplify, then we will find out minus of 35 by 36 to the power n. 1 we will take in this side, so it is minus half. So minus minus cancel means sign will be, that means the inequality sign will change, that is less than to greater than it will convert it. Now we take the log on both sides, so that we will find out after taking log on both sides, we will find out log of here it is n we will take out. So n into log 35 minus 36 greater than, here it is log 1 minus log 2. Log 1 0 we know, so that n should be greater than, it is minus of log 2 divided by log 35 minus log 36. That minus we can adjust and we will write log 2 divided by log 36 minus log 35, which is approximately equals to 24.6. Therefore, we can say that total the number of throws definitely not in fractions. So the nearest whole number is 25. So n should be greater or equals to 25, which is the minimum number of throws. And that's the answer. Now the next question is, two players A and B toss a die alternatively. He who first throw a 6 wins the game. If A begins, what is the probability that he wins? And what is the probability of B winning the game? So A and B, there are two players and one dice is there and they are throwing it alternately. Who get the first 6 will win the game. And A begins the game. So here events are given. Let us consider the event E1. A gets a 6 in the first toss. E2, A fails, then B fails, then A gets the 6, then only A can win. No? Then E3 is the A fail, B fail, again A fail, B fail, and then A wins. That means first time it is not getting 6, not getting 6, not getting 6, again not getting 6, then A gets the 6, then he wins. So in this way it may continues infinitely. That means till A gets 6 it will continue, and it is provided that B definitely gets not gets the 6 so that A can win. So here probability of getting 6 is 1 by 6 and probability of not getting 6 is definitely 5 by 6. And the elementary events in successive trials are independent. It is very obvious that the 1 to second trial is independent. They are not harming each other. Therefore, the probability of E1 is 1 by 6 and the probability of E2 is first A fails, that means 5 by 6, then B fails, 5 by 6, then A wins, that means 1 by 6. So its probability is 5 by 6, its whole square 1 by 6. Then probability of E3 is A fails, B fails, again A fails, B fails, then A success, so that this is. So and so on, it will continue. Now using the theorem of total probability, we will find out that the probability that A wins is equals to probability of E1 plus probability of E2 plus probability of E3. In this way it is going up to infinity. So that we just substitute the values, and after that now we can take 1 by 6 common from all those terms, so that it is 1 plus 5 by 6 its whole square, then 5 plus of 5 by 6 its whole to the power 4, plus in this way it will a GP series with the common ratio 5 by 6 its whole square. So that if we solve the infinite GP series, then it is 1 by 6 is the common term, then it is 1 divided by 1 minus 5 by 6 is its whole square. If we simplify, we will find out it is 6 by 11. So this is the chance of winning of the player A. Now similarly, if we want to find out the probability of winning of B, then we will find out just same way, but as B gets the second chance. So the first A have to be throw non-6, that means A should be failure, that means its probability is 5 by 6, and B winner, its probability is 1 by 6. So in the first it will starts from 5 by 6 into 1 by 6, and now it will proceed. So that in all the term 5 by 6 into 1 by 6 is common. So if we take that common, then again the previous series we will find out, which is a GP series with same common ratio 5 by 6 its whole square. If we simplify, then we will find out it is 5 by 11 is the probability of winning the B of this match. Now one more question, and that is the final question for this video. So the question is, here a wire of length L is cut into 3 pieces. What is the probability that the 3 pieces forms a triangle? Just understand the question very carefully. A wire is given with length L. It has to be cut into 3 pieces. Now what is the probability that these 3 pieces form a triangle? First of all, any wire is given. If you cut it from any 3 positions, suppose one position is this one, second is this one, so then it is not possible to make a triangle. It is next to impossible. So there is a particular rule to cut the wire into 3 pieces so that it can form a triangle. We know few properties of the triangle. We know that a triangle means it have 3 sides always. So 3 sides have 3 different lengths. So let this lengths be x, y and this one. So this one means total is L. That's why I have taken this one. So at first we can just initially assume that x value can be between 0 to L, because the entire wire is of length L. So x should be lies in between 0 to L. Similarly y also lies in between 0 to L. And the third side should be L is the total length. So L minus x plus y. So this one wire cutted into 3 pieces means L should be divided into 3 pieces. Suppose it is L1, L2, L3. So their addition should be L. Now as it forms the triangle, these 3 pieces should form a triangle. So let L1 is x, L2 is y, and L3 is L minus x plus y. So that we can present in a pictorial manner also. So this is our x-axis suppose, and this is our y-axis suppose. So x value can have at most L, and y value also can have L at most. Now if these 3 pieces L1, L2, L3 forms a triangle, then we know from the properties of the triangle that the addition or the sum of the any 2 sides of a triangle should be greater than the length of the third side of the triangle. So if it is so, then we can initially say that L1 plus L2 should be greater than L3. L1 we know it is x as per our assumption, and L2 is y, and L3 is L minus x plus y. So that if we substitute all this, then we will find out from here x plus y greater than L minus x plus y. So if we take it in this side, then it is 2 into x plus y greater than L, so that it is x plus y is greater than L by 2. So this is the first equation which we will find out. Again L1 plus L3 greater than L2. So L1 means x, L3 means L minus x minus y, and L2 means y. If we simplify, we will find out y is less than L by 2. Similarly, the last thing is L2 plus L3 is greater than 1, and if we simplify, then we will find out x is less than 1 by 2. 2. And as x and y values all are positive, so that we definitely write y should lies in between 0 to L by 2, x also lies in between 0 to L by 2. Now let us plot these three equations. One equation is this one, second equation is this one, and the third equation is this one. If we plot these three inequalities in a graph, then what we will find out? Now x less than equals to less than L by 2 means x value, x axis is this one, so x always L by 2 means here we can take this one is the graph, and as it is less than, so it is always in this side. Again, y is less than L by 2 or y equals to L by 2 means this one, and as it is less than, so it is always in this direction. Again, one more, x plus y is greater than L by 2. So x plus y means this straight line. If we join these 2 points, then we will find out the straight line. This one is x plus y straight line. This one is greater than L by 2. So that this direction is always this way. So the common portion is what? Here the common portion among all these three inequalities, the common portion we will find out this part now. So this one is the common portion, I think. This is the common portion which we will find out from here. So this one is the favorable case. If the length lies in between this triangle, then we can say the triangle will be formed by the three pieces, otherwise not. Again here, that means the favorable cases are here. If the values lies in between this triangle, then it is the favorable cases that the given wire cut it into three pieces and it will forms the triangle. And the total number of cases can be possible. X can have the value up to L, y can have the value up to L, and if we join these two lines, then this one is the boundary, so that maximum value can be, or maximum value for the x and y values are accordingly, and this is the portion which is the sample space we can say. Hence the probability, if we want to find out, then if we will find out the area of this triangle, this is the favorable area and this is the sample area, so that the probability should be favorable area divided by the sample area. Now if we want to find out the area of this triangle, so this one is a right angle triangle, its length is L by 2, this length is L by 2, this is height and base we can say, so that the area of this triangle is half into base into height, so that we can say half into L by 2 into L by 2. So the triangular area, the smaller favorable area is equals to half into L by 2 into L by 2. And the total sample area, if we consider this larger triangle, then its base and height should be L and L. So the sample area should be is equals to half into L into L. If we take the division of these two, then it is the required probability. That means what is the probability that the three pieces form a triangle? Its probability we will find out. So that the required probability for, we can write it is half into L by 2 into L by 2 divided by half into L into L. So if we simplify, then we will find out from here, it is LL cancel out and half cancel out. So it is 1 by 4 by 1. So that one is equals to 1 by 4. So 1 by 4 is the probability that the wire cutted into three pieces forms a triangle. So that's all. I hope you like the video. If you really like and enjoy the video, then please do like and subscribe my channel. Have a nice day. Thank you all.